Hey everyone, it's Zach here. Today I'm going to walk through a new demo that I've been showing a lot of customers and is really exciting to me, and it's the AAP Vault integration using OIDC. So this is going to allow us to scale out our automation but do so securely and have a trusted relationship between AAP and Vault as a secrets manager to pull secrets at runtime but also not have that long-lived credential zero sitting in AAP, which has access to all those secrets in Vault. This is going to leverage OIDC to validate the workload and the initiator of the automation on the Vault side to determine whether or not access to that secret should be allowed. So I'm going to walk through a quick animation of what's going to happen, and then we'll dive into a demo. So here I've got this diagram starting out with an automator, right? So this is the Ansible here. He's hopping into AAP and he needs to do some type of automation, but he needs elevated privileges that require reaching out to HashiCorp Vault. So AAP is going to provide an OIDC token and send it over to HashiCorp Vault. Now, what does that token entail? Let's dive into what those claims look like. So here's an example of some of the claims that are coming from AAP, which Vault can leverage to evaluate against whether or not the secret should be allowed. So you'll see here there's a few high-level things. The sub being the user, meaning a combo of the workload attributes, right? So the type of attribute, the organization, and then the job template. You can also see several other fields here. With each of these fields that's by name, there's also an ID. So you might want to write your policies based on IDs. That's fine as well. I simplified it so it wasn't overwhelming. But you can see here there's a lot of different things we can leverage to determine access, right? It could be the username. It could be the organization, the inventory, the execution environment, the project, right? Any of these things that are important to whether or not a secret should be accessible can be used when we develop our Vault policies. So moving on to that next step, when AAP sends over those JWT claims, Vault's going to evaluate it. The first thing is, as part of the Vault JWT engine, is what's called a role. So AAP is going to request a role via the lookup plugin, which we'll see in a moment. And that role is going to tell Vault kind of the early stages of the application. So what access policies should be applied, as well as some other things. So to start, we're providing the audience. So is this token coming to the correct audience, right? That's my Vault instance. Bound claims. So bound claims are basically saying the organization name needs to be in these two orgs, right? So that would prevent somebody from in the networking org to try to use this particular role. It would get denied right away. We have this other concept called claim mappings, and this is really helpful for writing dynamic policies. So in this case, I'm mapping some of the claims we saw in the JWT token to just some variable names that I can then use when I'm authoring my policies. And then the last thing is I'm giving policies. So I may have more than one policy. I might just have one, which we can actually see on the right there. This is a very simple policy saying for this particular path, so secret data AAP, and then I'm using that variable that I've mapped, so the organization name. So anything under that path in my Vault, the capabilities are read, right? Which is what AAP is trying to do. So what's really cool here, though, is that the claims are coming at runtime, right? And then Vault has these policies that it's going to evaluate against them. So those can be managed separately. And there's no long-lived token that has read access to this particular path. It's granted at runtime. And by default, it actually expires based on the configured job timeout of the job template. So a short-lived token that's intended to only live for the life of the job itself. So now let's go back and see what happens next. So let's say Vault says, okay, you're allowed to access a secret. It's going to give AAP a short-lived token. AAP is then going to be able to use that token to retrieve the secret it needs for elevated access. And then finally, we can automate everything, right? Or what the secret gives us access to. And you can think about this in the future as well, where we might have even more granular workload identity. So I encourage everyone to take a look at Spiffy Inspire as far as identifying workloads and where they're coming from. You can imagine those coming through as far as helping to identify agents, right, that may be triggering automation, and helping us to secure our secrets so that agents only have access to what they should. So now let's hop into the actual demo. So the first thing I want to show is in the repo that's the source for this particular blog post, I have a role for managing Vault. And there's a playbook for setting up Vault with a few different deployment methods. I'm using Podman for this particular demo, and I want to prove to you that I've already run it. For the sake of time, I'm not going to run it in this demo, but I've got this script that's going to give me a nice status of my Vault instance running via Podman. So I've got a rootless Podman running as my user. I've got a container up. I use Quadlet, so that's my Quadlet unit file to, make sure this container and service survives a reboot. If you keep scrolling down, just some additional details around the service itself. So this all came from me running the setup Vault playbook. I've set it up and torn it down several times, and it takes just about 60 seconds to spin it up and configure it. So it also sets up the JWT auth. It sets up a couple demo users for me. So there's a lot of things that you can do as far as within your automation itself. So now let's go into log into Vault, check out what it looks like on the Vault side, and then we'll go into AAP to see the actual integration. And we'll see that I'm in a new Vault instance. Cubbyhole is kind of the default secrets engine that shows up when you install Vault from scratch. I created an engine as part of the automation called Secret, which is a Key Vault secret engine. We can go in here and we can see we have Secret, AAP, and we have two organizations. We have Autodotes and Default. And I'm going to use that to show both the allow and deny outcomes. And then within there, we have just an Autodotes service account, dummy credential that we're going to use. We can also go into access control and see some different policies. So we can see our policy dynamic that I showed in the animation. And we can go to authentication methods as well and see our JWT auth is enabled. So now that that's been set up, we're actually ready to use, on the AAP side of things, the integration. So I'm going to log into AAP here, and you have to enable a feature flag for this particular setup, which is documented in the blog post itself. But once you do, you have this new credential type that's called the HashiCorp Vault Secret Lookup, and then it has OIDC in parentheses. And when you set this credential up, you can see there's some links, there's some information here that can help you set it up, but also the automation helps kind of give you some of these values. So we have our Vault server URL that I just stood up, passed to the authentication engine. So in my case, I just left the default JWT. You can customize that on the Vault side. The role that I want, right? So I remember I mentioned the lookup requires requesting a role. So that's the name of the role. And then the API version and namespace, which I'm just using default values there. So what I'm going to do here first is just go ahead and do a quick test to show you what it looks like. So the name of the secret backend was secret. The path was data AAP, Autodotes, and then Autodotes SA. The path to the auth is, again, that JWT. The key name was within that Autodotes SA, I have a key called client secret. And then I'm just going to pick a random job template because I'm really just testing on the org itself. So if I run that test, you'll see that my test passed, meaning my configuration is good. And you can see some example claims, right? And I mentioned that the IDs also get sent over the wire with the name. So let's close this out and actually walk through some of the use cases for the credential type itself. So I have some additional credentials. Let me search OIDC here. So I have one that's set up for an allow and one set up for deny. And what I'm doing here is I'm going to leverage a job template in the Autodotes organization, and I'll show what it looks like when I try to request a secret in the right path versus in the default path, because the Autodotes and default org are two different orgs. So let me go to this particular job template, which is just a basic demo job template. It's also in the repository, and it's just trying to retrieve a secret. So I'm going to first launch it with my allow credential. I'll click finish. And this is going through the OIDC integration process right here, and it's pulling the value, which was just GUID, so it's dummy secret. But that pull is actually doing the flow we saw in the animation. So now what I want to do is go back to the template, and let's go back to OIDC. and I'm going to run it again, but this time instead of using the allow credential, I'm going to use the deny credential, which is configured to point at a credential in the default org path. And we'll see here that this is going to fail because AAP is going to try to reach out to Vault, and Vault's going to deny usage of this particular credential. So you see we ran into an error, and we see that, forbidden for URL, and we see the default. And that's that policy, that dynamic policy getting applied, where it took the claim mapping for the organization name, it injected it into the policy, and it was like, well, this doesn't match, so you can't read this particular secret. So with that, I'll hop back over to the blog just to call out some references that I have that are very helpful when you're going through this process. I highly encourage you to read through this because it has a lot of the details that I may have glossed over a little bit. But if you scroll down to the bottom, we have the official Red Hat docs for setting up the config. This is just the high-level README from my repository. Then you have my setup playbook. So if you want to install Vault via Podman, this setup playbook will help you do that using the role. And if you want to dive into the role and get a little bit more into the weeds, take a look at that role. So I hope you enjoyed that. I think this is going to be really important, especially as we move forward into agentic workloads. And I see AAP as playing an important role in that, being that trusted layer for executing automation, where we're leveraging agents to go out and gather information, but we don't necessarily want agents making right changes in production. So I hope you enjoyed that. Happy automating. I'll see you next time.